In this proof by contradiction, we have several statements. We've told that A is a rational number. So we are given the fact that A can be written in the format of P over Q, for example. Now, B is an irrational number, and we're asked to prove that A plus B is irrational. So what we're going to do, the assumption we're going to make is that A plus B can be written in the format of a rational number. We're going to assume the opposite of what we're being asked to show. We're being asked to show that it's irrational, so we're going to assume actually that the complete opposite. We're going to assume that it is rational and see what happens. So in terms of my proof, it's going to be, well, if A plus B, well, I know what A is. A is a rational number. I've been given that as a statement, okay, and I'm saying therefore that P over Q plus whatever this irrational number is, okay, is going to equal to a rational number. Therefore B, which is this irrational, I suppose I should actually overtly write out, okay, B is irrational. Just the notation for that is I could say that it's a real number less rational. So that's the description that describes irrational numbers using set notation. So B, okay, must therefore be the rational number m over n minus P over Q and that can be tied up to be a single fraction, but this is rational. Okay, so I've just found that B is a rational number. If A is rational and the sum of A plus B is rational, that's my assumption, therefore B must also be rational. But that contradicts the statement, okay, that I had originally, okay? But B is irrational, okay? So basically, this statement here is impossible. So therefore, assumption incorrect. So it is impossible to assume that A plus B is rational. Therefore, we can say that A plus B is going to be irrational if A is rational and B is irrational. So again, using sort of notation, I could say that if A is a rational number and B is an irrational number, we can say that A plus B is going to be, as an answer, it's going to be irrational. Just one minor point I should have stated at the beginning there. When we state that something is rational, we should also state, I forgot to state, that P, okay, and Q can be any integer. Okay, and I should state that Q should not equal naught. Likewise here, M and N are integer values and N is not equal to naught. It doesn't really matter too much in terms of the proof, but it's just making sure we're being very specific about our definition of what a rational number is, or how we describe a rational number.